In today's video, we're going to see how to extract a number from a string. So I have already created this assembly language function here that's called uint32 from string. So as the name implies, it will extract an unsigned 32-bit integer from a string. So what's happening here? We receive the string in RSI. In RAX, we'll get the result. So this can actually be a 64-bit number, but I've called it like this because in the rest of my videos I've targeted 32-bit numbers, but actually this function will work with 64-bit integers as well. So also in RSI, we'll get the next position in the string following the number. So RSI will be incremented and it will be positioned right after the number. So let's see what's happening here. As in my previous videos, I'm starting by saving on the stack the registers that may be affected during the function. And at the end of the function, I'm restoring the register values. And of course, I'm calling red. So now let's see. I'm setting rax to 0. So this will be the result. I'm also setting here rbx to 0. And in R8, I'm setting 10. And you will see why. So what's happening here in BL register, so that's the lower 8 bits from RBX register. So in BL, I'm reading the current character pointed by RSI. I'm checking to see if this is a digit, so I am comparing with the character 0 and with the character 9. I've used here this particular conditional jump. You can implement with other types of conditional jumps. There was no particular reason for me to use this. I just wanted to use it. So if we detect something that's not a digit character, then we'll jump to this done label here, which will restore the registers and will return. So whatever we have already read in RAX, it will be returned. So assuming we got a digit in BL, first we subtract the ASCII code associated with 0. So at this moment in BL, we actually have a number corresponding to the digit that was read, a number between 0 and 9 inclusive. Now we are multiplying the current value of rax with R8. So remember, this multiplication instruction will actually affect both RDX and RAX, but at this moment we are not interested in RDX. Then we add RBX, which is our digit, to RAX. So what's happening here, assuming we already have something like 12 in RAX, and in BL we got, say, a 3. Then first by multiplying with 10, so remember R8 is 10, RAX will be 120, and now if we got a 3 in RBX, it will be added, so we got 123. Then RSI is incremented to the next digit, and we continue the loop. Okay, so at each step we multiply the currently processed number by 10, and we add the new digit, and it's quite easy to do. And we end this loop when we encounter a character that is not a digit. And that's it. And as I said, this can actually be called also wint64 from string. I will probably add an alias like wint64 from string here. So in case you're interested in 32-bit, you will just use EAX. If you're interested in 64-bit, then you use the complete RAX register. Okay, so now I have here a second function, which is reading an signed integer. So this previous one, as you saw, it didn't check for minus sign, so it's only reading an unsigned integer. While in this one, we'll check for plus or minus, so we can read a signed integer. So let's see what's happening here. Again, in RSI, we received a string, and in RAX, we'll get the result. And RSI will be advanced after the number. So what we are doing here, we are actually internally reusing the previous function, but we are also checking to see if prior to the number we got a plus or a minus sign. Okay, so if we got a plus sign, the register R8 will be set to 0. If we got a minus sign, the register R8 will be set to 1. Also, in both cases, RSI will be incremented so that we move to the first digit in the string. Also, in the case that we didn't get neither plus nor minus, as you can see here, we have a jump past this increment, so we get directly here. So it's possible to read either a number that starts with a plus or a number that starts with a minus, or a number that does not start with a sign. So it works in all three cases. And now we are calling the previous function that we already discussed, that's reading the unsigned number. And following this, we check if we have R8 set to 1. And remember, R8 will be set to 1 here if we had a minus sign. So if this is the case, then we'll basically perform 0 minus the number that was read. And it's possible to implement this with some other instructions like negating the number and subtracting 1 and stuff like that. But in my case, I decided to use this particular approach where I'm moving the number in R8, I'm setting RAX to 0, and then I'm subtracting R8 from RAX. And so we get basically 0 minus the unsigned number, and this is the number that was read. And that's it. We restore the register R8, which was saved at the beginning of the function, and we return. And now, as usually, let's take a look at a very simple test program. So what I have here, I'm setting RSI to a string that contains numbers. Let's take a look at it. So this is my number string. As you can see, there are 5 numbers in this string. Also, at the end of the string, there must be an end character. This can be a 0, a space, a new line, whatever. And we need this because, as you saw in the functions, we processed character by character until we found something that was not a digit. So we do need to have some character here. And I also have this variable here, this constant here, the number of numbers in this string. And so I'm setting RSI to the string. RCX is the number of numbers in this string. Now I'm calling the unsigned integer from string. Then I'm turning it back to a string that gets displayed. And I have already created videos for transforming a number to a string and for displaying a string. I'll give links in the description. So basically the number gets read as an integer, it's in rocks, then it's converted back into a string, and then that particular string is displayed. And I have here the buffer that will be filled with the string representation of the number, and this will be displayed. And then because here the function already advanced RSI after the number, which is basically a space, I'm incrementing RSI so that it moves past that space. And finally, I'm looping back here. And remember, this will decrement RCX. So we loop as long as we still have numbers left to read. So until we reach numbers that were read. And finally, I'm exiting to the operating system. So I hope you found this interesting. And if so, don't forget to like and subscribe, and see you next time. Bye.